Hello, this is Mrs. Brown, and today we're looking at Polynomial Basics. So hopefully you have your notes template in front of you so that you can fill that in. And we're going to look at a series of just notes. Remember, you can always pause it and fill stuff in if you don't have enough time to fill it in as I'm talking. Okay, so we're going to start with some basic vocabulary words. Polynomial is just the monomial or the sum of monomials, and you can see some examples over there. Monomial we talked about in a previous lesson with a more extended definition, but it's basically a single term, remember. And here are some examples. There's certain things it can't be, like you can't divide by a variable, those sorts of things. So if you don't remember, go back to the previous lesson. Binomial is the sum of two monomials. So it can be a plus sign or a minus sign because remember, subtracting a positive number is the same as adding a negative number. So this is also considered a binomial. Trinomials are the sum of three monomials. So again, you can see the examples where it's three things that are, three terms that are added together. Okay, so let's take a look at some of the things that we're going to be doing. Okay. So one of the things you're going to be doing in this lesson is calculating the degree of a monomial, okay? And that's a fancy way of saying the sum of the exponents of all of the variables. So when you're looking at the first example, 9x, remember when a variable is by itself, it's just x. It has a degree, it has an exponent of 1, so the degree is 1. When you look at 4x to the 9th, y to the 3rd, that's degree 12 because 9 plus 3 is 12. When you look at 5x to the 3rd, that's degree 3 because it's to the 3rd power. Okay, this is not to be confused with your product rule. So don't start thinking that you can combine the x and y exponents. You can't. It's a different skill. So we're just looking at the degree, and the degree is the sum of all the exponents no matter what the bases are. But the product rule, you have to have the same base, and that's when we're multiplying together to simplify. So those are two different skills. So make sure you kind of keep those separate because this is one point where sometimes your thoughts get a little bit scrambled and you actually mix those two things up. So make sure that you understand that this is totally different. We're not simplifying anything. We're just finding the degree by adding the exponents of the variables, okay? So a degree of a polynomial is going to be the highest degree of any term. And so, for instance, if you look here, the 2 is the highest degree, so therefore it's a degree 2. Here, the 3 plus 4 is 7, 2 plus 3 is 5, so degree 7 is the highest one, so that's the degree of the polynomial. Okay. The standard form of a polynomial, not to be confused with the standard form when we were graphing linear equations back in first semester. So terms are ordered from greatest to least degree. So the standard form of a polynomial, you find the degree and the highest one goes first, and then the next one, and then the next one. So for instance, this is a degree 3, degree 1, degree 0, because it doesn't have a variable with it. All right, and then the leading coefficient, if you're in standard form, is just going to be the first coefficient, the coefficient of the first term. So if you have it in standard form, leading coefficient is just going to be the number that is the coefficient for the first term. Okay, so that's some vocabulary. We name polynomials based on their degree. So here are your degree names. A 0 is a constant, so that's just like a number, like the number 8. Okay. Linear would be degree 1. Those are the things like if you think about graphing slope-intercept form and standard form that we talked about before, those are linear equations and they're degree 1. When you start looking at quadratic, that's going to be things that are squared, degree 2. Or you can combine like an x, y together, and that would be 2. Cubic would be 3, quartic would be 4, quintic would be 5, and then when we get to 6 or more, you'll just say like 6th degree, 7th degree, 8th degree, so on. So if it was a 13, when you added it up, it'd be the 13th degree, okay? So again, if you didn't get this written down, you can pause it and fill in your notes table. Okay. That leaves us with our final bit of information. Let's just apply some of the stuff that we just talked about. So if I give you the expression 7, Is it a polynomial? Yes, because it's a constant and it's a real number. And so therefore, the degree is 0 because I do not have an exponent with a variable. And so that's a constant, and there's only one term, so it's a monomial. If I look at this one, okay, yes, this is a polynomial because it's the sum of 3 monomials. You can see them separated by addition or subtraction signs, so you can see there's 3 terms. It's quartic because it's degree 4. The first term has a degree of 4, and that's the highest, and so that's quartic. And then there's 3 terms, so it's a trinomial. If you look at 8m to the negative 2, this is not a polynomial because I'm dividing by m to the second. So this actually simplifies to this, and this is not a monomial. So therefore it's not a polynomial. And so there's nothing here because it doesn't apply. Okay. Finally, this one, 4x plus 7 plus 2x. Yes, it's a polynomial. However, it's not simplified. So before we determine the degree, before we determine the type and all this kind of stuff, we're going to simplify it. And so this is the same as 6x plus 7 because 4x and 2x. And so it's the sum of 2 monomials. The highest degree is 1, so therefore it's linear. And it is 2 terms, so it is a binomial. Again, if you didn't get your stuff filled in for your table, you can pause it, fill it in, and remember to submit an image, okay? If you have any questions, you know where to find me. Have a great day.